In this segment, we'll be covering I/O testing and demonstrating the bandwidth capability of the D5000 platform. For this demo, we'll demonstrate the D5800 using 48 3.5-inch Enterprise HDD across the D5800 and a J5800 JBOD, as well as 4 optional Enterprise SSD in the D5800 for caching. We'll demonstrate ISCSI performance followed by NAS performance. The D5000 is a flexible storage platform that allows various configurations depending on your performance needs and budget. Data center administrators can take advantage of block-level access through Fiber Channel or ISCSI, or simply deploy a NAS environment for file-level access and services, or a combination of all of the above. In this example, we've got the VTrak D5800 RAID head, a VTrak J5800 JBOD, a 10 gigabit optical Ethernet switch, a 1 gigabit Ethernet switch for management, and a 1U server that contains a 10 gigabit SFP plus Ethernet HBA PCI card to take advantage of ISCSI and NAS performance. We'll be presenting 2 block devices to our server running Windows Server 2012 R2 via ISCSI. Note, we cannot max out the bandwidth capability of the box with our current setup, since we only have one workstation server either running ISCSI or NAS with dual 10 gigabit Ethernet connection. To max out bandwidth, we would need 1. 72 plus HDD or 24 SSD, 2. Enough workstations and servers that can consume the available bandwidth. In this example, we have 2 storage pools, one pool affinitive to controller 1 and the other to controller 2. In order to take full advantage of the D5000's powerful dual Broadwell DE processors, we want to make sure the 2 storage pools are balanced amongst both controllers. Note, for best performance, it's best to ensure jumbo frames are enabled on the host, switch, and storage. Note, for Windows 2012 R2, we recommend to either use Promise Perfect Path or Windows Embedded MPIO. Perfect Path and MPIO both allow you to set load balance policy. Default is failover, you can set it to round robin, least queue depth, etc. You can download Perfect Path for Windows 2012 R2 from our download center. For Windows 2016, you'll need to use Windows MPIO. Here's a quick overview on establishing the ISCSI connection. Open your ISCSI initiator properties and go to the Targets tab. Type the storage IP 10.10.10.10 and click Connect. It'll automatically add the target. Go to the Discovery tab. There you'll find it automatically. As you can see, it found both target IPs, including 20.20.20.10. Click on the Favorites tab and click Refresh. Then click OK. Next, open Webpam Pro E and add the initiator. Go to ISCSI Management and click on Logged In Device, then Add to Initiator List. That's it, it's that simple. Now that we've presented the block-level device volumes from the storage pool, we will enter the disk management utility and use NTFS on our 2 block-level devices that we presented to the server and create a software stripe. These LUNs can either be accessed individually or in a stripe set. We will stripe them so we can access both LUNs simultaneously. Please note that for the performance test, we'll be accessing the raw LUNs using IO meter. Now let's access the NTFS striped volume through Windows Explorer. As you can see, the volume is mounted and ready for use. We're now ready to run some basic IO tests. We will be accessing the raw LUNs to demonstrate line rate on both online ports. Here, we're running IO meter to demonstrate 1 megabyte sequential write-read performance on the D5000 and 4K IOPS. As you can see, we have 3 workloads. One workload for 1 megabyte sequential writes, and one for 1 megabyte sequential reads, and lastly for 4K IOPS. Let's run each one. As you can see, we get the line rate for both reads and writes at 80,000s plus on 4K IOPS. very respectable performance. As you can see, we are nowhere near the maximum throughput output of the D5000 platform. The D5800 can output up to 4,214 megabytes per second read and 3,376 megabytes per second write, assuming it's not drive-bound. In this configuration, we're bottlenecked by the server's available bandwidth and not the storage. Now that we've demonstrated block-level access through 10 gigabit ISCSI, let's go over how we would access the storage as a NAS. In this demonstration, we're configuring a NAS share and have disabled the previous ISCSI configuration and deleted the volumes leaving the storage pool. In order to create a NAS share, a storage pool must first be created. In our setup, this has already been done, so let's review. The D5000 has the flexibility to run the following protocols: NFS, FTP, SMB, and HTTP. In addition, NAS shares support thin provisioning and customizable share sizes. For Mac OS customers that would like to take advantage of the Time Machine support, the D5000 series allows this feature to be enabled per share basis. Now that we've completed configuring our NAS share, let's go over the networking configuration of the D5000. You can see that in our I/O port configuration, we have both 10 gigabit ports on each controller up and active. As you can see, our IPs previously set are still configured the same. First portal has IP address 10.10.10.10 with a Class C subnet. Second portal has IP address 20.20.20.10 also with a Class C subnet. Also, our host IP settings have not changed. Now that we know our IPs to the controller's portals, let's go over permissions for the share. You can create users and groups internally in the D5000 series. Let's click on NAS account. Once these users are created, we can set ACLs for all the NAS users within the D5000 GUI. In our demo, we're simply granting read-write access. Note, for D5000s joined to a domain, you can modify Windows ACL setting. This requires enabling ACLs in the protocol settings. In our case, we're using SMB and using the internal option. Now that we've added read and write permissions to the NAS user, let's mount the share. As you can see, we're now mounted. Let's spot check the performance. For this test, we will run Blackmagic disk speed test. Let's have a look. As you can see, we're getting close to the line rate. Note, Mac OS users are encouraged to disable SMB signing to get the best performance from the D5000. This concludes the D5000 series mount and access demo. For tips on configuring storage devices, please visit kb.promise.com or reference the product user manual. In our next video, we'll show you how to access Promise's top-notch technical support for the VTrak D5000 series.